issue with this drain is when there's heavy rain, all the water is gonna flood into this drain and fill it up really fast. There's gonna be lots of runoff of chemicals and oil from the street that goes straight into our water system. There's gonna be, it could overflow the drainage system, and then we get sewage bubbling up everywhere. And then it could cause flooding later on, or it could cause flooding here, and then this whole street floods, and then no one can go anywhere, and it's raining, and it's so bad. I know! Why don't we replace this area with a nice park?
How would that work?
Because the water would flow into the ground instead of into this drainage ditch here.
Okay, so here is the current state of the parking lot. You can see the drain over there is labeled with a D, and that's the issue because the drain floods and then the sidewalk floods. Now in the projected plan, you can see there's room for lots of trees right next to the drain. There's also trash cans to stop trash from getting into the drain. Hopefully people will put their trash in the trash can. There's also a little park, like bench seating area for people to go outside and eat lunch because there's classes in the building right next to it. It's with permeable pavement so that the water can still like get into the ground so we cause less flooding. And ideally the parking lot as well would be made out of permeable pavement so that we can still help reduce the flooding. Also, you can see the difference in the parking spots only differs slightly. Not that many people park there in the first place when I walk by, so.
So what are the benefits of replacing this little area within a parking lot with grass instead of the concrete that's there today? Well, this particular area has a decline where when it rains, all the water pours into this little spot and overflows onto the sidewalk and just sits there. But if we replace this concrete with something like grass, which is a permeable surface, when it rains, the water would go into the ground and be able to drain from the area. This would result in a greater groundwater recharge and less flooding within the area.
Columbia's water supply comes from wells that access an alluvial water aquifer formed by sand and gravel deposits left by melting glaciers along the Missouri River. This aquifer, filled with 44 billion gallons of water, acts as a natural filtration system and is continuously replenished by groundwater. The wells are about 110 feet deep, reaching the aquifer's bottom. In March 2017, the Integrated Water Resource Plan, or the IWRP, was finalized to establish strategies for a sustainable and cost-efficient water supply. Additionally, since 1992, a partnership involving the U.S. Geographical Survey, the City of Columbia, and the Missouri Department of Conservation has monitored groundwater quality in the McBain Bottoms. This monitoring aims to track changes in water quality and protect the public supply well field, ensuring safe drinking water for the community.
Hello. Today we're going to talk about the streams and creeks in Columbia and where they lead. The two main ones that we're going to talk about are the Flat Branch Creek and Mill Creek. Flat Branch Creek you've probably heard of, especially since it's right next to campus. It's right next to the spot that we highlighted. And both of those creeks, which are pretty significant, drain into the Hinkson Creek in Columbia, which picks up nearly all of the water drainage within Boone County.
So to kind of visualize that, we have a little map of Missouri right here. We are in Boone County, which is right here. And basically from Boone County, all of the water drainage flows into this river, which is the Missouri River. And also from all around Boone County, other rivers like the Blackwater River, the Lamine River, and drainage from the Lake of the Ozarks all flow into the Missouri River, which ends up on the side of Missouri into the Mississippi River, which eventually drains into the Gulf of Mexico. So all of that water and all of that pollution from the streams that pick up that pollution flow into the Mississippi River and into the ocean.